Welcome to ReneEnergy.com on YouTube, the hub for all things renewable energy and sustainability. Our channel is dedicated to bringing you the latest innovations and insights in green energy, including cutting-edge developments like green hydrogen. Whether you're a sustainability veteran or just beginning your journey, we have something for everyone. Join us on this channel to explore inspiring projects for a sustainable tomorrow. We bring you the latest in renewable energy, sustainability, and cutting-edge technologies. And don't forget, for more in-depth information and resources, visit our website and subscribe to our newsletter for the latest updates and exclusive content. Welcome back to ReneEnergy.com YouTube channel, your go-to source for renewable energy insights. In this section, we explore how digital technologies, particularly artificial intelligence, AI, and the Internet of Things, IoT, are revolutionizing green hydrogen production and integration. These advancements are pivotal in making green hydrogen more efficient, cost-effective, and scalable. The role of artificial intelligence, AI. AI is playing a crucial role in optimizing various stages of green hydrogen production. One of the primary applications is in the operation of electrolyzers, which are essential for splitting water into hydrogen and oxygen using renewable electricity. AI algorithms can analyze vast amounts of data from these processes to predict and control various parameters, significantly enhancing efficiency, quality, and safety while reducing capital expenditures, CapEx. For instance, AI-driven predictive maintenance can forecast equipment failures before they occur, minimizing downtime and maintenance costs. AI-enabled simulations provide critical insights during the feasibility study stages of green hydrogen projects. These simulations can answer questions about power availability from renewable sources, the number of electrolyzers needed, expected capacity utilization, and energy demand. By incorporating renewable energy models, weather forecasts, and electricity market prices, these simulations optimize the sizing and operational strategies, ensuring economic viability and minimal environmental impact from the outset. Additionally, AI is instrumental in the design and operation of renewable electricity generation assets, such as wind turbines and solar panels. By analyzing data on wind patterns, solar irradiance, and other environmental factors, AI can determine the optimal placement and design of these assets, maximizing energy production and reducing losses due to inefficiencies like the wake effect. This capability ensures that green hydrogen production facilities are supplied with the maximum possible renewable energy, enhancing their overall efficiency. The Internet of Things, IoT. The IoT enhances green hydrogen production by enabling real-time monitoring and control of the entire ecosystem. IoT devices equipped with sensors and connectivity collect and transmit data on the condition and performance of various components, such as electrolyzers, storage tanks, and pipelines. This data is then analyzed using AI and machine learning, ML, to optimize operations continuously. For example, IoT platforms can monitor the health of hydrogen storage systems, ensuring safety and efficiency in storage and transport. Moreover, IoT facilitates the integration of renewable energy sources with hydrogen production plants. By analyzing data on renewable energy generation and consumption patterns, IoT systems can dynamically adjust hydrogen production rates to match the availability of renewable energy, thereby maximizing efficiency and reducing wastage. This integration is crucial for balancing the intermittent nature of renewable energy sources, ensuring a stable and continuous supply of green hydrogen. Digital twins. A digital twin is a virtual replica of a physical system that is used for simulation, analysis, and optimization. In the context of green hydrogen, digital twins enable comprehensive monitoring and control of hydrogen production facilities. They integrate data from various sensors and operational systems to provide a holistic view of the plant's performance. AI enhances these digital twins by running what-if scenarios and predicting future outcomes based on current data, which helps in proactive decision-making and optimization. Digital twins can simulate the entire life cycle of a hydrogen production facility, from initial design and construction to operation and maintenance. This capability allows operators to test different scenarios and strategies in a virtual environment, identifying the most efficient and cost-effective approaches before implementing them in the real world. This reduces risks and ensures that green hydrogen plants operate at peak efficiency from day one. Energy management systems, EMS. EMS are pivotal in coupling hydrogen production with renewable energy generation and electric grids. These systems use AI to optimize the entire production process, from renewable energy forecasting to hydrogen storage and distribution. An EMS can control distributed energy resources, DERs, such as solar panels, wind turbines, and batteries, ensuring that hydrogen production is aligned with energy availability and demand. This integration reduces operational costs and enhances the overall efficiency of green hydrogen plants. An EMS advisor, typically a cloud-based AI platform, interfaces with EMS controllers to connect, monitor, and control all distributed energy resources. These controllers manage photovoltaic, PV, systems, wind turbines, batteries, backup generators, and grid connectivity. AI-based predictive control algorithms deployed in EMS optimize the green hydrogen plant's operations by considering factors like renewable energy forecasts, existing power purchase agreements, spot market prices, electrolyzer characteristics, hydrogen demand, storage capacity, and production forecasts. This holistic approach ensures that the green hydrogen plant operates efficiently, maximizing hydrogen production while minimizing energy consumption and operational costs. Case studies and projects. One notable example is the High AI project, a collaboration between H2Go Power, the European Marine Energy Centre, EMEC, and Imperial College London. This project uses AI to optimize hydrogen production and storage by integrating weather data, electricity prices, and energy usage patterns. Initial results have shown improvements in the cost-effectiveness of hydrogen production and a reduction in power grid stress. Another example is H2 Green Steel, which utilizes digital tools to optimize hydrogen production processes, aiming to produce green steel with the lowest possible costs. Their software solutions assist in planning the configuration of hydrogen plants, making the design process more efficient and cost-effective. By leveraging data-driven optimization, H2 Green Steel can achieve significant cost reductions and efficiency gains, positioning itself as a leader in the green hydrogen and green steel industries. Conclusion. The integration of AI and IoT and green hydrogen technology is a game changer, driving efficiency, reducing costs, and enabling the scalable deployment of hydrogen as a clean energy source. By leveraging these digital technologies, the green hydrogen sector can overcome many of the current challenges and move towards a more sustainable and economically viable future. By understanding and supporting these advancements, we can collectively move towards a cleaner, more sustainable future. Don't forget to like, share, and subscribe for more insights into the world of renewable energy. Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode enlightening and motivating. There's a world of innovation and opportunity in sustainable energy, and we're delighted to share this journey with you. Stay in the loop with the latest on renewable energy and sustainability by visiting our website and subscribing to our newsletter. Your support is immensely appreciated, it's truly invaluable to us. Don't miss our next video on new trends in renewable energy. Follow us on social media for the latest updates. Enjoyed the video? Like, subscribe, and share for more green insights. Thanks for watching.